In this video, we're going to look at right triangle trig. So a right triangle means I have a triangle where one of my angles is 90 degrees, and that's usually denoted by a box in that corner. The side opposite to that right triangle, or if you think of opposite as directly across from it, is called the hypotenuse, and then the other two sides are called legs. So if I give you a right triangle, but I tell you that I'm coming from a specific corner, then the hypotenuse stays the same, but my legs now have new names for them. So the leg opposite, if I'm coming from the angle, the bottom right hand corner angle, the leg opposite to that is called the opposite leg, and the leg adjacent or next to that one is called the adjacent leg. All right, so that can switch up if I tell you to come from the other angle. If I tell you to come from the top angle this time, then the hypotenuse stays the same, but the side opposite is now at the bottom, and the adjacent side, or the adjacent leg, is now on the left-hand side of the screen. So knowing which one's opposite and adjacent is a really big part of trig. So one reason we need to know which sides are opposite, adjacent, and hypotenuse is because we have 6 trig functions, and these 6 trig functions deal directly with the legs and the sides of the triangle. So the first trig function is sine, and that trig function is simply the opposite leg over the hypotenuse. The next trig function we have is cosine. That one is the adjacent leg over the hypotenuse. And then the third one we have is tangent. It's supposed to be a T, which is the opposite leg over the adjacent leg. All right, so these are our main 3 trig functions: sine, cosine, and tangent. Then we have 3 more. So the reciprocal of sine, and when I say reciprocal, I mean the fraction flipped, is cosecant. So I flip the sign, so instead of having opposite over hypotenuse, I have hypotenuse over the opposite. The reciprocal of cosine, or cosine flipped, is secant, so that gives me hypotenuse over adjacent. And then the reciprocal of tangent is cotangent, so that one is adjacent over opposite. So we have these 3 that are reciprocals of the first 3. All right, so what you should do is you should remember that sine and cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals. An example that you might see in this section is, what are the 6, my handwriting on this is a little bad, 6 trig functions of the triangle So what are the 6 trig functions of the triangle? And I'll give you a triangle, and I have to tell you what angle I'm coming from. So if this is my right triangle, this time I'm coming from this angle, and it's usually denoted by a Greek letter. So an example you might see in this section is, what are the 6 trig functions? and I have to tell you what angle I'm coming from. So if I give you a triangle, and right now we're only dealing with right triangles, and I tell you I'm coming from this angle, I'll denote it theta, and usually it's the Greek alphabet letter. So alpha, theta, beta is what you would normally see. And I tell you that this side is 4, the bottom side is 3, and the hypotenuse is 5. And I'll ask you to find what sine of theta is. I'll ask you to find what cosine theta is. I'll ask you to find what tangent theta is. I'll ask you to find cosecant theta, secant theta, and cotangent theta. So sine is opposite over hypotenuse. In this case, the opposite side coming from theta is 4, and the hypotenuse is 5. So it's simply 4 over 5 would be my sine theta. Cosine is the adjacent over the hypotenuse. So the adjacent is 3. The hypotenuse is 5. So this one would be 3 over 5. Tangent is opposite, which is 4, over the adjacent, which is 3. So this one is opposite over adjacent, which is 4 over 3. Cosecant is simply sine flipped, so cosecant is going to be 5 over 4. Secant is 5 over 3 because it's cosine flipped. And cotangent is tangent flipped, so it's 3 over 4. So that's why it's helpful to remember that cosecant, secant, and cotangent are reciprocals of the first 3, because once I found the first 3, all I have to do is flip them to get the next 3. The next example we're going to look at is going to be just like the last one. I'm asking you what are the 6 trig functions, and I give you a triangle, and I have to tell you what angle I'm coming from. So this time I'm coming from the top angle, which is going to be my alpha. And what makes this one tougher than the last example is I'm only giving you 2 sides. So if you only have 2 sides of the triangle, you have to do the Pythagorean Theory. And hopefully we all remember that one, which is a squared plus b squared equals c squared. So you're doing the Pythagorean Theory, where this time I'm giving you a and b. So c is always the hypotenuse. So remember that c is always the hypotenuse. So this time I'm missing the hypotenuse. So I do 2 squared plus 4 squared equals c squared. 2 squared plus 4 squared gives me 20. So c is going to equal the square root of 20. So my missing side is the square root of 20, but I need to make sure that I reduce that. So square root of 20 can be broken down to the square root of 4 times 5, where 4 is a perfect square. So that is going to be 2 times the square root of 5. So my c is equal to 2 square root of 5. All right, so c is equal to 2 square root of 5. Once I've done that, then I want to find the 6 trig functions, just like I did in the last example. I'm going to turn to a new page, so bear with me. The same triangle, and I just found that my hypotenuse was 2 square root of 5. So now if I want to find sine, and I'm coming from alpha. Remember, I'm coming from alpha this time, so sine is opposite over hypotenuse. In this case, my opposite is 2. My hypotenuse is 2 square root of 5. So that gives me 2 times 2 root 5, or I should say 2 over 2 root 5. So from here you can see that the 2's would cancel out. That leaves me 1 over root 5. But I need to rationalize my denominator. To do that, I always multiply by whatever the square root is on the bottom. So in this case, square root of 5. 1 times the square root of 5 up top just gives me the square root of 5. On the bottom, square root of 5 times the square root of 5 gives me 5, no more square root. So my answer here is square root of 5 over 5. I do the same thing for cosine. And this should be cosine theta, just like this one should have been sine theta. But cosine theta is adjacent over hypotenuse, which is the adjacent this time is 4. So 4 over 2 root 5. You can see that 4 over 2 reduces to 2 over 1, so I have 2 over root 5. And then I rationalize the denominator the same way. So I multiply by root 5 top and bottom. That gives me 2 root 5 over 5 for my cosine theta. Or alpha. Keep saying theta, but it's alpha this time. So then we move to tangent. So I have tangent of alpha, which I keep forgetting to write, is opposite over adjacent. So my opposite here is 2, and my adjacent side is 4, so it's 2 over 4, which simply reduces to 1 over 2. So those are the first three, sine, cosine, and tangent. Then I remember that my reciprocal of sine is cosecant, so cosecant of alpha. I normally just want to flip this one, but if I grab it at the end and flip it, I'm going to have 5 over root 5, and that'll give me a square root on the bottom. So instead of grabbing it at the end, I'm going to grab it up here at the beginning after I reduce the 2's. I said that it was square root of 5 over 1. So if I flip that, I get square root of 5 over 1, which is just the square root of 5. So my cosecant is square root of 5. Square root of 5. My secant alpha is the reciprocal of cosine. So I'm going to do the same thing with my cosine. I'm going to go in and grab it before I rationalize the denominator. And if I flip it there, I simply get square root of 5 over 2, which cannot be reduced. And then my tangent, I am actually going to grab this one at the very end. I don't need tangent, I need cotangent. My cotangent I'm going to grab at the very end because it was simply 2 over 1, so that's just going to be 2. So those are my 6 trig functions. It's just like the previous example, but this one I had to actually find my missing side. Then I had a square root, which when I have a square root on the bottom, I have to rationalize the denominator.